In this video, we're going to learn how to draw Lewis structures for neutral atoms and ions. Lewis structures are representations of atoms or ions that just focuses on the valence electrons. Remember, the valence electrons are those electrons in the final shell, the valence shell, in other words. So this doesn't mean that chlorine has 7 electrons only, it just means that it has 7 valence electrons in its last shell. And remember that you can find the number of valence electrons by looking at the group that the elements are in. So group 1 is 1, group 2 is 2, skip the 3 to 12, group 13 is 3, then 4, then 5, then 6, then 7, then 8, except for helium, which has 2, because it only has its first shell. So that's a reminder of how many valence electrons you can have. So we'll do some examples. If you want to draw a Lewis structure for, let's say, sodium, what you would do first is you would simply draw the symbol for sodium. You would go look at what group it's in. Here's sodium, group 1. So it has 1 valence electron, and you would place 1 dot. If you want to draw the Lewis structure for magnesium, you could try it yourself. Pause the video. Try it yourself. Mg is the symbol. Magnesium is in group 2. There's 12 electrons, but there's 2 valence electrons. So you just have to put 2 dots around the magnesium. I usually place them singly first, then pair them after. And I go clockwise, so single, single, and then pair if I need to. Now suppose you want to draw it for chlorine. Chlorine, you would draw the symbol first. Chlorine is in group 17, so 7 valence electrons. So I would place 1 here, 2, 3, 4, 5, 6, and then 7. So it has 3 paired electrons and then 1 single electron. So this doesn't mean, again, that these have 1, 2, and 7 electrons. It means that they have 1 valence electron, 2 valence electrons, 7 valence electrons. And everything else is still there, just represented by the symbol. And that's because when we do bonding and chemical reactions, it's really just the valence electrons that are participating and not the other ones. So now we're going to try to do a Lewis structure for ions. So suppose you want to draw the Lewis structure for the sodium ion. So what I do first is I draw the regular ion, sodium. Notice it has 1 valence electron. So to form an ion, you ask yourself, is it easier to gain 7 to be like a noble gas or to lose 1? And so basically it's less than halfway there, so it's easier for it to lose 1. So what we would draw is sodium without that valence electron in brackets. And because it lost 1, we'd put plus or 1 plus. Let's look at magnesium. Magnesium, if I want to draw the ion, okay, you'd see it has 2 valence electrons, so you ask yourself, is it easier to lose 2 or gain 6? It's still easier to lose in this case. So we draw magnesium without electrons because it lost them to make the ion, but it lost 2 electrons this time, so it would be 2 plus. Now let's say you want to draw the chloride ion. Normally it has 7 valence electrons, and you ask yourself, is it easier to gain 1 or lose 7? Well, it's easier to gain 1 to get to 8 than lose 7 to get to 8 below. So easier to gain 1. So we're going to redraw chlorine with the 1 that it gained. There's the one it gained. We're going to put a bracket around it, and then we're going to put charge 1 minus. If it gained 2, it would have been 2 minus. So notice that metals, you don't draw any electrons around them because they lose it. And then you put the square brackets and you put the charges. Non-metals, you draw all the electrons around them because they gain, and then you put square brackets and you put the charges. So pause the video, try these ones out here, and I will take them up. So let's go take a look at Se. Se is in group 16. So that means that it has 6 valence electrons. So 1, 2, 3, 4, 5, and 6. Li. Don't confuse the dot on the I for an electron. Li is in group 1, so it has 1 valence electron. Na we saw before in group 1, so 1 valence electron. Oxygen ion, this is different now. So oxygen ion is in group 16. So oxygen is 1, 2, 3, 4, 5, 6. We want the ion. Oxygen, we have to ask ourselves, is it easier to gain 2 to get to 8 or lose 6? It's easier to gain 2. So I'm going to draw this as x and x. You can draw them as dots, but just put them as x's to show you that I've added 2. So I'll put my square bracket here, and I'll put 2 minus. Phosphorus ion, which is phosphide, right? Oxygen ion is named oxide. Phosphorus ion is named phosphide. You'll learn that in more details later. But phosphorus is in group 15, so 1, 2, 3, 4, 5. Is it easier to lose 5 or gain 3 to get to 8? We're more than halfway there. So it's easier to gain 3. So I'll put 1 here, and 1 here. They can be drawn as dots, but I'm putting them as X's to make it more apparent to you. So since we added 3 electrons, we're 3 minus, and that's the phosphorus ion. So in this video, we learned about Lewis structures to represent neutral elements and also ions. This is the way you'll typically do it in grade 11 and also for the bulk of grade 10 because it's just easier to show bonding with valence electrons instead of having to do Bohr-Rutherford diagrams every single time. In the next video, we're going to show the formation of ionic compounds using Lewis structures. For now, make sure you understand Lewis dot diagrams for elements and ions.